your very kind cooperation and patience. So you want me to take off? Okay, we take off. So, but this point is very crucial. Here mu takes values, we want to make it a mu vector. Here mu takes value 0, 1 to 9. So it's a mu vector in the target space, but this is a scalar field. Okay, scalar field with respect to the word sheet, super word sheet. Okay, so because super word sheet does not know mu, so or with respect to super word sheet, it transforms like a scalar. Okay, whereas it transforms like a mu vector with respect to the target space coordinates. Okay, and this I identify with my usual bosonic string coordinate, which is function of sigma alpha. And this psi mu is also a function of sigma alpha, but psi mu is fermionic. And this B mu is an additional field that we have got as a bonus, as a gift. And this, so we would formulate the entire theory retaining this. These are called as the component superfields. This is the superfield. X mu, psi mu, and B mu, they are called as the component superfields. Okay? Because they are components of the superfield by mu. And whenever we put B mu equal to 0, which is an Euler-Lagrange equation of motion for this field mu, then that theory would be called as the Onel theory, and that theory would be identical with the RNS. So from this formalism, we can reduce it. When we go to the gauge fixing condition, gauge B mu equal to 0, translate this theory into the RNS superstring. This is what we mean. Okay, so now we can go further. Okay, now let's have a look at the following things. One thing we have made sure is our psi mu A, which is psi minus psi mu plus, my theta A would be theta minus theta plus. Okay. So just like my psi is two component Majorana spinner, my theta is also a component Majorana spinner. However, and when I have supersymmetric transformation parameter epsilon, this would also be epsilon minus 1 plus. So epsilon would also be a two component Majorana spinner. However, epsilon and theta they are constants. So they are not fields. Whereas this field, because this each one psi mu is a function of sigma. Okay, so they are the fields. Psi mu is a field, but these are not fields. Okay, they are constant and they are Fermi coordinates. Okay. Good. This would be eventually the gauge parameter of the supersymmetric transformations. Okay. Right. So now we want to make use of these three things, and we can generate a whole lot of or the properties of the Grassmann variables, and a few that are important for us. We can note down here that sigma alpha is enlarged to sigma alpha theta A, and theta A they are, so let me not use this symbol here anymore, so that I do not confuse you with that. So theta A anti-commutes theta A, theta B plus theta A, theta B, theta A equals to 0, and this in particular would tell you that also sigma alpha and sigma beta, they would commute. Okay, so sigma alpha, sigma beta minus sigma beta, sigma alpha, this is equal to 0. Also, sigma alpha and beta A, they also commute. Okay, so sigma alpha beta minus sigma alpha beta minus, and this is quite obvious. Both of them are bosonic variables. They are like x in quantum mechanics. Okay, so the commutator of x with x would vanish. So this sigma and sigma beta, they would commute, and sigma is bosonic fermionic, so they also commute. But theta with theta anti-commutes. Okay, so this is the anti-commutative relation. If you like, you can write anti-commutative relation. Okay, and now we introduce a new concept which is called as supercharge. So supercharge is, let me first write down the expression Q of A. This is defined as del over theta A minus rho alpha theta A del. We define an object denoted by capital UA in terms of these theta variables, and our old matrix of the gamma matrices that we had in the RNS superstring theory. So they are same standard, I think 0, minus 1, 1, 0, and something like this. Okay, rho 1 and rho 3, and so they stay the same. They are rho alpha are rho matrices of the RNS superstring, whatever we had. So we keep the same notation. Okay, we have to keep in mind that definition of rho 0 is always very important because it is involved in the definition of theta bar, epsilon bar, sigma bar, psi bar. Okay, the Dirac conjugate. Okay, Dirac conjugate, psi bar, or okay, theta bar or epsilon bar, all these things, because they involve the gamma 0. Okay, so I think psi bar is psi dagger I rho 0, right? So they, and this also applies to our theta. So theta bar would be theta dagger I rho 0. You can find out what it is, and the same when I introduce epsilon bar, it would be the same epsilon dagger I rho 0. So keeping in mind, what I want to emphasize here is the definition of rho 0. Whenever you are reading different, I mean the articles by different people, always look for the definition of what is rho 0. What rho 0 rho? Because that can change the entire algebra. It would be different. Concept would be the same, consistent by within itself, but it might look different. Okay, so because the definition of 0 would change. Okay, so you will have biotite, some don't biotite. There are many representations for this which you can look at. So now these objects QA are called as supercharge. Why do we need a supercharge, and what do they do? They act on the superspace points and they generate the supersymmetry transformation, which we derive out explicitly. Okay, so therefore they are the generators of the supersymmetry. The supercharges are generator of they are the supersymmetry. So they generate the supersymmetry transformation. And how do they act? QA acts on one sheet coordinates in the following manner. How does it act? So epsilon r q sigma alpha would be epsilon var. Now q is there, so del over del theta is r minus rho theta del beta, and this acts on sigma alpha. I want to see how the supercharge act on sigma alpha. So it acts in the following manner. Now if you develop this would be epsilon var del over del theta a var of sigma alpha, which would be eventually 0, the first term, minus epsilon var rho beta theta. Del beta is